We're going to talk about the new affordable luxury and exotic food, the lab-grown meat. In January 2019, a single bluefin tuna sold for 333 million yen, or equal around 1.6 million pounds. One fish, enough to buy a house in most countries. Bluefin tuna population have experienced a massive declines, with Pacific bluefin dropping to less than 5% of their original biomass, and Atlantic bluefin once declining by over 80% from historical levels. Japanese unagi freshwater eel has become so scarce that the price have tripled in the past decade, and foie gras, a luxury so controversial that it's been banned in several countries, yet the demand keeps growing. But what if I told you that a revolution is happening, not to replace your everyday chicken nuggets or ground beef, but to recreate the world's most expensive, most exclusive, most endangered delicacies without ever harming an animal. Welcome to the world of lab-grown luxury food, and the science behind it is more brilliant than you might think. We start from the problem with the cheap meat strategy. So, for years, the cultivated meat industry had a single obsession, which is make lab-grown beef cheaper than a regular beef. The logic seems simple. If you can match the price of a $5 per pound burger, so we will think that everyone will switch. But here's the problem. The problem is nobody wanted to talk about it. In 2013, the first lab-grown burger cost 246,000 pounds to produce. That's not a typo. It's 240,000 pounds just for one hamburger patty. Now, the costs have dropped dramatically, which show in 2024 study published in Nature Food. It demonstrates that using continuous manufacturing techniques, cultivated chicken could theoretically be produced for around 4.63 pounds per pound, approaching price parity with organic chicken. Some companies like Gourmet claim production costs as low as €7 per kilogram. That's remarkable progress, but conventional ground beef, still around $5 per pound, and according to techno-economic analysis, achieving price parity with commodity meats remains one of the industry's greatest challenges. And here's why is the gap so hard to close. First, traditional farming has had thousands of years to optimize. Cows essentially turning grass, which is free, into meat. They munch the grass and they produce meat and milk. So they don't really need ultra-sterile facility like when we go to the laboratorium, and they don't need expensive growth factors. They also don't need electricity bills for these bioreactors. A scoping review published in Nature Food in 2024 conclude that under current technological paradigms, cultivated meat is unlikely to be competitive with conventional meat without significant further innovation. Competing with traditional farming on price for commodity meat is like trying to be the marathon runner while carrying a big refrigerator on your back. But some brilliant entrepreneurs ask a different question. What if we are targeting the wrong market all this time? Think about it mathematically. Sounds simple, but if we think about it again, if lab-grown meat costs around 38 pounds per pound to produce, you need to cut costs by 90% to compete with 5 pounds beef. That's nearly impossible. But bluefin tuna toro, the fatty belly, considered the wagyu of the sea, sells for over 75 pounds per kilogram, while Japanese unagi 50 to 70 pounds per kilogram. Premium foie gras, it also has the similar territory. Suddenly, the 38 pounds production cost isn't a problem anymore. It's already competitive. So you don't need to revolutionize your technology, you just need to pick the right battlefield. Lunalu, a San Diego-based company, conducted a techno-economic analysis suggesting they could achieve profit margins exceeding 70% with their cultivated bluefin tuna toro sold at price parity with conventional tuna. This is called price parity strategy, and it's changing everything. You already know the economic aspect of it. Now, let's get into the fascinating science. Don't worry, I'll keep this simple. So, how does it work? Every piece of meat is made of cells, muscle cells, fat cells, connective tissue, and all the cells contain all the instructions to build meat, encoded in their DNA. Scientists start by taking a tiny sample smaller than a grain rice, from a living animal. This can be done with a simple biopsy, which causing no more discomfort than a blood test. The animal walks away unharmed. And from the sample, they isolate the stem cells. It's like a special cells that have the ability to multiply and transform into different type of tissue. After they isolate the stem cell, the cells then placed in the bioreactor. Think of it as an artificial womb, a warm bath of nutrients that mimics the condition inside the animal's body. The liquid, called growth medium, contains everything that cells need, such as, for example, amino acids for building proteins, sugar for energy, vitamins, minerals, and special molecules called growth factors that tells the cells to multiply. A major breakthrough came in 2022 when researchers developed a serum-free media formulations, which eliminating the need for animal-derived components entirely. And the other study in 2024 by Naturfood demonstrated animal component-free culture medium costing just 50 pence per liter, or it's just like half pounds of it. So in this perfect condition, cells divide rapidly. One cells become two, two become four, and four become eight, and so on. The continuous manufacturing process achieves cell densities of 130 billion cells per liter, and that's almost 43% yield by weight. And after all that steps, here where it gets really interesting. By changing the recipe of the growth medium, scientists can tell cells what they have to become. How? How does it work on lean muscle? Adjust the signals, and stem cells transform into muscle fibers, the protein-rich tissue that gives meat its texture and chew. One rich marbling fat like bluefin tuna toro, different signals trigger fat cells development. So companies like WandaFish have developed proprietary techniques to achieve the same beautiful marbling pattern you'd find in wild caught fish. And the final challenge, this is the biggest challenge they face on this lab meat development. It is the structure of the meat itself. A pile of cells isn't a meat, it's just a mush. So for products like minced meat or sausages, this is not a problem. But for whole cut steak or a piece of sashimi, we really need the architecture. Scientists use edible scaffolds. Think of them like a building framework that gives cells a structure to grow on. As cells multiply and mature, they organize themselves into familiar patterns of real meat. The scaffold is absorbed or become part of the final product that we consume. And all of that complicated science and technique. So we must get into the next objective. So we're thinking beyond the taste. We think to design better nutrition. The new consideration lab-grown meat isn't just about copying nature, but it's about the potential to improve on it. When you grow cell in a controlled environment, you can tweak the recipe. So for example, omega-3 fatty acids, the healthy health fats found in fish are incredibly valuable for human health. They reduce inflammation, protect your health, and also support brain function. While bluefin tuna naturally accumulates omega-3s because of their diet, but cultivated meat offers something revolutionary, the ability to design the nutritional profile. According to the Good Food Institute, improvements in nutrition may be possible by tailoring cell culture media ingredients for desired outcomes, such as increased omega-3 fatty acids or higher vitamin and mineral content. Researcher also has demonstrated tunable levels of intramuscular fat. The deeper we get, the more interesting we also get. And if we're going a bit more controversial, what if we could use this genetic modification not just to make meat taste better, but make it way more healthier? So, nearly half of cultivated meat companies are exploring genetic engineering for either research and commercial use that we have talked about that before. And so now let's address the elephant in the room. Is this stuff actually safe, and is it really better for the planet? So we are talking about food safety here. In terms of safety, cultivated meat offers some significant advantages because it's produced in sterile conditions, and there's no risk of contamination with pathogens, like, for example, E. coli, Salmonella, that typically come from animal intestines. For seafood products, there's no mercury, no microplastic, nor parasites. And the regulatory approvals are rigorous. Food Standards Australia, New Zealand assessed pho cultivated quail and found the quail cell line to be genetically stable, with microbiological risks manageable through standard food safety control. So, at the end, if we talk about the future of our plate, imagine a life where foie gras without force feeding, exotic meats without hunting, luxury without guilt, or even crazier, maybe, just maybe, we could see humans could have a bodybuilder-like muscle mass and body shape without even going to the gym. They only have to inject the stem cells. It sounds crazy, but what if it's achievable in the future? And the technology also exists. The regulatory pathways are being established, the companies are scaling up. So now, the question isn't whether this feature will arrive, but it's whether you'll be ready to taste it. So, lab-grown luxury meat is like turning yesterday's impossibility into tomorrow's menu.